Right, so today I'm going to be talking about DAGs and Dask, but first I will talk a little bit about myself. I'm Katharine Jarmul. I'm originally from Los Angeles, where the first PyLadies chapter started. It's really exciting to be able to meet people doing PyLadies Prague and all over the world. It feels very heartwarming, and I'm really happy to see the community growing, and Django Girls and everything else that's been discussed. You can find me at KJam on most everything, GitHub, Freenode, and Twitter, and my website is kjamistan.com. So, pardon my language on my slides, but I am American, so I curse a lot. So, what the fuck is big data? These are things that make you question, right? Everybody wants to talk about big data, but what really is big data? I'll give you a minute. So I find big data often being used as this punchline for jokes, and that's because big data has become the punchline, right? You have all these big data experts, big data advocates, but a lot of times when you start talking with them, there's little beyond that, right? The understanding of big data is just, I use Hadoop, or I use this or that, and therefore I use big data. And I think that that is a really big problem within the data community because it doesn't further the conversation of what is really big data and when we actually do need to use distributed data analysis. So what really is big data? I hate to break it to you, but you probably don't have big data. Even if you have big data, it can probably be analyzed using normal things like relational databases or non-relational databases. There's already been optimizations for quite a lot of that. And if you do have big data, but you need to do analysis, you likely only need to do analysis on a smaller filtered subset. So we have this problem that we're like, no, I have terabytes of data, it's so massive. And you get down to the actual question that you have, and it's usually quite smaller. So I would say first determine whether you actually have big data. So what are DAGs? It sounds like dogs, right? But what are DAGs? We're going to go into that. And so DAGs are based on graph theory. They're first developed by Leonhard Euler, and he used it to determine the Königsberg bridge problem. And graphs essentially are DAGs, but also graph theory is essentially used in nearly everything. So when you're using Facebook and they're recommending things to you, they're using graph theory. When you're asking Google to tell you the fastest directions to the next place that you're going to go, you're using graph analysis. And it's even used to study genetics. It's used to study terrorist node networks. It's used to study people. Probably some of you have already done graph theory, so I won't berate you with that. But what are directed acyclic graphs? Directed acyclic graphs, this is an example from Wikipedia, are ones where the nodes, which are the circles, and the edges, which are the arrows, are going in one direction, and they're acyclic, meaning if I start at any node, I cannot end up back at that node. Okay, Katharine, that's great. Thanks for the graph theory lesson. But what do DAGs have to do with my data, right? We're talking about data analysis. Why are you talking about graph theory? I don't really want to introduce graph analysis or a graph database into my setup. The last time I installed Neo4j, it crashed my computer. Okay, so we're going to talk about MapReduce. So MapReduce is a common big data problem, right? I have my data distributed. I need to map it with a certain key or output, and then I need to reduce it to sum over my key or to do an average over my key, whatever it is. And so here's an example of visualization of a MapReduce problem, and what does it look like? Do we have nodes and we have edges, right? Is it acyclic? Is it directed? Yes, okay, so MapReduce is a DAG. Let's talk about a more complex data pipeline. This is an example from Databricks, and of course they're promoting the usage of their tools. So there's Kafka in there, there's Spark, and you're moving your data through a pipeline, right, into the end inputs where you're running GraphX or MLlib or something else to do large-scale analysis on your entire data pipeline. And what does this look like? You have nodes, you have edges, it's acyclic, and it's directed. Okay, so my first lesson or takeaway I hope you take away is to stop building scripts, trying to do everything yourself, and just let graph theory and directed acyclic graphs do it all for you. Right? So you can utilize these DAGs to take your data and move it through the operations without you running this script, then that script, then the next script. So what can Dask do? Dask can parallelize common data types. It can manage your workflows by creating and building your own DAGs. It can distribute your work across your local system or your larger cluster. So I don't know if you've seen this before, but usually when you're running Python, this is what you're doing. So you don't want to do that, right? So how Dask can help you avoid being that. So for our Dask data types, right, we have 3 main simple data types. We have a Dask array, which is essentially just a distributed NumPy array. It doesn't have all of the features of a NumPy array or all of the methods, but it does have quite a few. We have a Dask data frame, which is essentially just a distributed Pandas data frame. As you can imagine, distributing a Pandas data frame is slightly more complex, and therefore it has less features than arrays in terms of the features that mimic those available in Pandas. And then we have a Dask bag. And this is a multi-set, which essentially just means it's a collection of Python objects. We usually use it for strings. And it is non-unique, so it can have duplicates. It's very similar to if you've used Apache Spark for text analysis. It operates very similarly. And then we also have Dask delayed. So this is slightly more complex. And what this allows you to do is to create functions. You could, I guess, also apply it to classes. And it allows you to build complex workflows through just using method decorators and a few other things. So you could essentially, that script that you have that you're like, Katharine, I still want to use my script, it's really awesome. Okay, you can use your script, but use it with Dask delayed and build out your custom graph. And it does have optimized parallelization. It has last in, last out, and that allows you to finish a full workflow before moving on to the next one. And this helps, they've found, with memory consumption. So I'm going to do a live demo, and luckily I was initially going to do one in the cloud, but I decided after seeing some internet mistakes yesterday that I would just do it locally. So all of these notebooks will be available. They're actually already on my GitHub, but I'll put a link to them. So first we're going to just do a little bit with Dask data types, and then we're going to move on to Dask distributed, which is the ability to distribute work across multiple workers. Okay, so can everybody see this? Read the code in the back too? Yeah, okay. You can read it? Kind of. Okay, I will try to zoom a little bit. Okay. So I'm going to just import from Dask, and we're going to first take a look at arrays, which is really easy. So I'm going to do a binomial distribution array with just 1,000. So if we see here, we'll check that it is indeed 1,000. So if I take a look, when I call a slice on my array, I get this Dask array object back, right? And that's not very useful for me as a data person. I want to actually see the numbers. But what I'm getting at here, so I need to run compute, right? And then I actually get an array returned. So what Dask does here is it does lazy evaluation of everything. So everything is built, and then lazily, then you need to call compute in order to evaluate it and actually get the return. And this is done so that it can optimize for you, right? It can decide, okay, you're doing this and then doing that, but I may or may not change some of the ordering, or I may or may not allocate workers or memory based on what you're building with your graph. So I can know that I have it over 10 partitions, and this is important when you're working with a distributed setup and you need to do sorts or shuffles or something like that. You need to know how many partitions across how many different computers you have. If I take a look at my chunks, I can see I passed in a chunk of 100. And I just did that for an example for us. Usually I would not even chunk something like this because it's only 1,000 numbers. But when you can start thinking about much larger data or even data that you, again, have distributed on numerous machines, chunking is going to be important to decide what can be held in memory. So you want to pick chunk sizes based on what can be held in memory. And if I visualize the minimum, so I'm going to call the minimum value, and I get this nice DAG, right? And what this is doing, I know it's too small to read, but what it's doing is from the bottom, is creating our random binomial distribution, and it's then deciding across all of the different partitions what is the minimum, and is aggregating that into a single final answer. And it just does it all for you. You don't have to do anything yourself. And as you can see, it can compute it in almost instantaneous. Okay, so we'll move on to parallelized pandas. So I am interested in open government, and I do some web scraping. And I was I helped run the PyData Berlin meetup group in Berlin, and we decided to do an analysis of European Parliament. And so I built a European Parliament scraper that goes to the European Parliament website, and it scrapes all of the speaker information and all of the speeches. So this is the data set I'm using. If you're familiar with pandas, you'll know head, right, which is just taking a look at the first 5 rows. And what I'm doing here, you can see I can call my operation and get everything. If you're not familiar with pandas and you want to learn more, I'm giving a talk a little bit later today on pandas. I can look at my D-types, which is great because I can see some floats in there. I might want to do some cleanup on this because not everything that I would expect to be a float is a float, but I can do that all in Dask. But here I see how many partitions is my pandas data frame on. It's my Dask data frame. Is it distributed? No, right? It's on one partition. That's fine. I can still lazily evaluate things. So I can call lock to get the index number 4 of my data frame and see the Twitter. And I can also create group by objects. So it does all of the things that you would expect normal pandas data frame to be able to do. Now, if I call my group by and I visualize it, so this is going to be grouping by nationality and current political group, I see just one massive graph, right? And this is because my data is not actually distributed. It's on one partition. Dask said it's not big enough to be distributed, so it's just going to perform it in a linear fashion, not parallel. So sometimes what I do when I have this problem and I'd like to distribute it, I just set a new index. So Dask can use the index to make intelligent decisions about partitioning. So I said, okay, there's this column speaker ID. It's a number, so maybe Dask will be able to understand that. No. So it's still only on one partition. All right, so I said, all right, I know that I can get the speaker ID values, and I have this massive array. And from this array, I can create partitions, right? So I'm simply taking 50 of them at a time, and I'm creating my partitions. Now, if I look at my partitions, it is a list for me. I can use Dask set partition to set those as the partition and also pass in the column name. So this is going to allow me to create those partitions of my data. And I now have 11 partitions. And if I look at the divisions, this is going to tell me, so this is great if Dask decides to do it for yourself and you want to see what's in your different partitions, you can use divisions, right? And so this is going to show me all of the different divisions. Finally, I can visualize this. And so I see that here at the bottom of my graph, this is where Dask is going to split up the data for me into the different partitions. And then when we get up here, it's going to perform parallel analysis of the grouping and then the sum. Finally, if I run it, I can see that I get back what I would expect, which is a data frame with a multi-index that allows me to see the different groupings. Okay. So moving on to Dask bags. Then we'll move on to distributed after this. So a Dask bag, again, is a multi-set. I can simply read in text. They have a few different other things that you can read in. This is going to be just all of the different speeches that I was able to scrape from the European Parliament site. And I can use take to just take a look at a few of them, right? Again, if you use Apache Spark, this seems very familiar. So if I take 2, I can see that I have some statements from the Swedish representatives here, but I could also filter. So what if I just wanted to filter on things that were that had check in the text, right? I can create a filter, and again, I get this lazy evaluated Dask bag. So if I take 3 of them to have a look, I can see that there's some different conversations happening, which involve the Czech Republic. So I'm gonna, scroll down here. And if I wanted to do some more analysis, what basically this is doing with the zoom, it's a bit hard to read, I'm going to split, concatenate, and then call word frequencies. And this is essentially a one-line operation to do word counts and then sort for me. So I'm gonna run that. I see that I get that same Dask bag, and if I want to compute it, I see that I can get the different analysis. And it's not very wonderful because I do need to do a little bit more cleanup, and I probably should use NLTK to get rid of stop words and things like that. But you can see that in one line, I'm able to parallelize across about 170,000 lines of text, and you can use much, much more than this, right? Okay, we're going to move on from that and talk about Dask distributed. So I'm gonna really quickly get this going. So Dask distributed is the ability to run your Dask data structures or functions across multiple nodes. So I'm gonna quickly run my imports and start my client. So it's that simple to start a client. I'm running it locally, but you can easily run it on any cloud instance. I also have a few that I run just on AWS and in my cloud. So once I call client, then it started a local client. It just chooses the number of cores. So I have 8 cores, and we can see that that starts a nice little window for me where I have this status. This is a bit hard to see, but I'll show you. And this is gonna keep track of memory, network, and has your task stream and progress. So we're gonna define a few functions, and this is just really silly stuff. It's doing some math, it's sleeping for a certain amount of time, and it's mainly to show that you can create any number of functions, and then you can have them run on your distributed, and it's going to do different things. So what I'm gonna do is I'm calling this map, and as I call that, you can see it start to run, right? And this is going to map all of those tasks across my client. If I call this, I get all these futures, and these futures are these returns that are going to eventually finish, and at that point in time, I can get their result if they have a return, of course. I can use gather to gather them across all of my mapped nodes and then say, okay, what are the results? If we see here, that is what Tornado is doing in the background. I can do math with errors, right? And this is starting to introduce exceptions. I can actually see all of the exceptions that it's loading and get their tracebacks. And I have some math in there to introduce zero division error. So you can easily pull those. And then I can do more different things. And these futures will take a lot longer because they introduce sleeps for random numbers of time. And at the end, what I can do is pull the results. And as we can see here, it will take a look at, I can see all of the different tasks coming in. I can see memory use across the different tasks. and this memory use, and then you can see on individual clusters and workers. So if you really want to dive in and dive down, it gives you quite a lot of different views. This is all running on a Boca server, and it all comes just shipped with Dask, so you don't have to do anything, which is really, really nice. So that's, again, I'm going to post the notebooks so you can run it yourself. I also have some other Dask notebooks, but I'm going to really quickly go back to my slides. So this is just a quick comparison that I did. I decided to run nothing too intensive. It's about 700,000 unique token analysis with word count in Python. It's just pure Python using simple generators and at the end a counter. Then I did the same thing in Dask bags, and on average, I did probably about 10 trial runs, so nothing massive. These were the variants that I saw within each run, and that probably had to do with whether my computer was doing other things. I ran them all locally. But I saw on average about a 30% speed increase. So again, we're not talking massive things, like you're not going to install Dask and then all of a sudden everything is going to be so fast and amazing. But if you're talking about dealing with a terabyte of data or more, then this can not only be a speed increase, but an economical increase, or decrease, I should say, for your team. So if you're working in the cloud and you're spending money on these large instances and GPUs or whatever it is you're doing, then using Dask may save you some time, which is going to save you some money. So you're like, oh, Katharine, that's awesome. Like, I'm just going to ditch Pandas and NumPy, and now I'm just only going to use Dask, and that's all I'm going to do. And I kind of agree, because I think Dask is awesome, but these are reasons why you shouldn't use Dask for everything. The first thing is that parallelization is not always obvious or simple. So you could think that something is simple and obvious and that you're parallelizing it in a good way, but it takes a lot of time to learn how to parallelize and optimize that. So sometimes you're actually adding time and work by parallelizing rather than decreasing, right? Python, depending on what version you're using, can do quite a lot of things very fast. And sometimes by parallelizing, and you're parallelizing in Python, not C or something, then you're actually just adding time. Your data set is probably small enough to just analyze on Postgres, to be honest. The creators of Dask even say that directly in their documentation. Unless you have a terabyte, I don't really know why you're using Dask. I disagree, because I do think sometimes I just find it efficient to analyze something on my computer with Dask, because I can easily parallelize it and take a look. But I do think that sometimes if you're talking about production use cases, you should think about actual databases that are optimized for those type of joins. It's a new library, so sometimes things break. I have had my fair share of trying to get some example that I found in Dask that only works in Python 2, ported to Py 3, and they're constantly introducing new methods and other things like that, so things are going to break, and they're working really quickly. They do about a new release every 2 or 3 months, which is awesome, but it also means, yeah, sometimes there's bugs. And sometimes you need more functionality. So if you actually want a full workflow, I recommend taking a look at Luigi or Airflow. You can also take a look at Spark too. Some people really like working with PySpark. Other people just think Spark is only for Scala folks. So, final tips. If you really want to speed up reading from disk, you need to use Dask-aware data types, such as Castra and HDF5. There's some really easy ways to import something from CSV and then outport it to Castra or outport it to HDF5. So if you're doing something repetitively, or if you're going to do more than one analysis, I recommend doing that first. Read through the documentation. It's actually really well written, and it has a lot of use cases in there, so you might get some ideas. If you want to use AWS, or if you're already using AWS, Dask EC2 allows you to have one line to start up a cluster and then distribute your work across that, which is really fun. Use the GitHub latest everything. Don't install Dask EC2 from pip, because they're constantly fixing bugs, so I want you to have the best experience. Experiment and play first. So this is not like, okay, let's pull all of the pandas that we have running out of production and we're just going to use Dask. What I say is that you want to experiment and play first and just see how Dask operates for you, and then work it into your workflow. So if you love data, I have to do a small, tiny little plug. I'm helping organize PyData Berlin 2017. We're looking for sponsors. We're looking for speakers. If you just want to attend and see way better talks than my talk, then come. It'll be awesome. And thank you so much. I have a bunch of things about where to find the notebooks. And yeah, I'm going to post the slides. And thanks for being here. Okay, so can you highlight differences between Dask and PySpark RDD data frames? So the main difference I would say is that you don't have to run Java. So the differences between PySpark data frames and Dask data frames is PySpark data frames do not try and replicate Pandas data frames. They have some of the similar functionality, but they don't by no means have any of the same methods. Because Dask uses Pandas actually behind the scenes and uses NumPy behind the scenes, then you don't have this problem sometimes that you have with PySpark, in which you're actually talking with Java objects and you have some like obfuscated problems, right? Dealing with Py4j or something like that. What did you use for collecting the data from the website? I did use Scrapey. I love Scrapey. If you haven't done Scrapey yet in terms of data scraping from the web, I highly recommend taking a look at it. They have great documentation, and it's based off of essentially a Start project within a Django project, so to speak.
You answered the last question already.
Okay. You seem to be running built-in methods on objects. How do I do arbitrary computation on the data? So I believe that this is asking, like, how do I parallelize something within Dask that doesn't use Dask objects? I don't know if that's correct. If so, then I recommend taking a look at Dask Delayed, which I talked about, which can just do some similar computation. Also, obviously, if you're using a Dask array, it's just a NumPy array. You can do normal Python on a NumPy array. You can use sorted and all of those things. If that's not the right question, or if I'm not answering the right question, then come find me, and I will try to explain it better. Thanks again.
Actually, we have some more time for questions, if anybody would like to raise their hand and ask. And if not, then thank you for the information, for the talk. Oh, you have.
Oh, sorry.
Hi, thank you for the inspiring talk. Dask looks really cool. I just wanted to ask, if you distribute your workload across different machines, do you have to set up identical environments everywhere, or does Dask automate that somehow?
So I would take a look, if you want to do it on your own, or if you want to use something other than Dask EC2, which I recommend if you're not in the cloud already, I would take a look through what Dask EC2 does. Essentially, it just creates a bunch of nodes, salts them, and then it installs Dask and starts Dask workers on them. If you don't want to run just C equal client, or like you're not using Jupyter Notebook, what it can give you is either an IPython shell, or you can essentially, with a bin script, start up all of the Dask scheduler, which is the main runner, and then each of the Dask workers. So then you just need to make sure that they're pointing to your head scheduler, right? So you have to do a little bit of tweaking, but with Ansible, I could see it taking like a half a day. So
Thank you.
no problem.
So this Dask DAG stuff looks a lot like data flow programming, and I have experience with real-time data flow programming, and I wonder if it has any of the functionality, like could I stream video or a lot of surveillance video, for example, to a cluster and process it, or does it only work with static data sets?
Yeah, so I know that they're interested in investigating some of that, because I do know that they've recently updated all of the streaming information, and they usually say, okay, like Dask is not really a streaming service. If you want to use a streaming service, like use Kafka and like write it to somewhere, or use PySpark and do PySpark streaming and then do the analysis on the data later. But I would guess that if they don't already have some way to hack that together now, that they will soon. So I would stay tuned. I know that Matthew Rockland is the main developer, but he has somebody that he recently hired to help with it. And I know that he's working on incorporating it with the machine learning tool set. And that's usually like one step behind. I need to data process and machine learn on my incoming data. So I would not be surprised if it's coming soon. As far as I know, that would require a little bit of munging on your side to make it work.
So how about some connectors to distributed storage? Are there, for example, S3 connector or some distributed databases or stuff like this?
Yeah, so they do have an S3 connector. They have something, they basically use glob. So you could essentially say, like, if you have a data store somewhere and it's in files or it's in Castra files or whatever it is, you can use the star operator like you would with Bash to basically expand, which is really nice. And they also have connectors for HDFS. So if you're already using HDFS. And I think that they're really, really open to suggestions there, because I think, they really want people to be useful. So if you use something different and there's not a connector yet, I think they'd be very open to either requests or pull requests. Yeah.
Right, I see no more questions. So thank you again.